Good morning, children. Today we have a special topic of discussion: dual nature of matter and radiation. Sir, what is this dual nature? What is the dual nature of this matter and radiation? See, before we understand that, I want you to understand what is matter and what is radiation. First, we are going to study what is radiation and what is matter and what are their characteristics. After studying this, what we are going to do? We are going to discuss about the dual nature. Okay. First, I will take radiation. What is this radiation? Radiation is what? Radiation is emission or transmission of energy. What is that? Emission or transmission of energy in the form of waves. ನಮಗೆ ಸನ್ನಿಂದ ಲೈಟ್ಗಳೆಲ್ಲ ಬರ್ತಿದೆ ಅಲ್ವಾ ಮಕ್ಕಳ? ಈಗ ಸನ್ ಲೈಟ್ ಬರುತ್ತೆ, ಹೀಟ್ ಬರುತ್ತೆ, ಬೇರೆ ಬೇರೆ ರೇಡಿಯೇಷನ್, ಯು ವಿ ರೇಸ್ ಬರ್ತಾ ಇದೆ. ಈ ಎಲ್ಲ ರೇಸ್ಗಳು ಏನಿದು? ಇದೆಲ್ಲದು ಕೂಡ ರೇಡಿಯೇಷನ್. ಸರ್, ವಾಟ್ ಈಸ್ ದ ರೇಡಿಯೇಷನ್? ಸರ್, ಬೇಸಿಕಲಿ ರೇಡಿಯೇಷನ್ ಇಸ್ ದ ಎನರ್ಜಿ emitted or transmitted in the form of waves. First we are going to write it. Okay. Radiation, emission or transmission of energy. Transmission of energy in form of what? How do these energy propagates? In the form of waves, generally transverse waves. Okay, energy in form of waves. ಎಲ್ಲೇ ರೇಡಿಯೇಷನ್ ಹೋಗ್ತಾ ಇದೆ ಅಂದರೆ ಅರ್ಥ ಏನು ಮಕ್ಕಳ? ರೇಡಿಯೇಷನ್ ಈಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಆಸ್ ಎ ವೇವ್, ವೇರ್ ಆಸ್ ಮ್ಯಾಟರ್. ವಿ ವಿಲ್ ಕಮ್ ಟು ಮ್ಯಾಟರ್. ಸೊ ಮ್ಯಾಟರ್, ಸಿ ವಾಟ್ ಇಸ್ ದಿಸ್ ಮ್ಯಾಟರ್? ಎನಿಥಿಂಗ್ ವಿಚ್ ಹಸ್ ಗಾಟ್ ಮಾಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಮ್ಯಾಟರ್. Matter is mass. Even from the electrons, protons and all these terrestrial objects we are seeing, what is this? Mass. Okay, so matter has got mass. And our entire universe is made up of only two category substance, that is, one is radiation and matter. ಸೊ ಜಗತ್ತಲ್ಲಿ ನೀವು ಇದೇ ನೋಡಿದ್ರು ಎಂಟೈರ್ ಯೂನಿವರ್ಸಲ್ಲಿ ಮಕ್ಕಳ, ಐದರ್ ಇಟ್ ಶುಡ್ ಬಿ ಎ ರೇಡಿಯೇಷನ್ ಆರ್ ಇಟ್ ಶುಡ್ ಬಿ ಎ ಮ್ಯಾಟರ್. ಇದನ್ನು ಬಿಟ್ಟು ಇಡೀ ಯೂನಿವರ್ಸಲ್ಲಿ ಬೇರೆ ಯಾವುದೇ ಪಾರ್ಟಿಕಲ್, ಇಲ್ಲಿ ತನಕ ಬೇರೆ ಯಾವುದೇ ಕೈಂಡ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ನಮಗಿನ್ನೂ ಗೊತ್ತಿಲ್ಲ. ಎವ್ರಿಥಿಂಗ್ ವಿ ನೋ ವಿ ಕ್ಯಾಟಗರೈಸ್ ಇನ್ ರೇಡಿಯೇಷನ್ ಆರ್ ಮ್ಯಾಟರ್. ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಇನ್ ದಿಸ್ ಡಿಸ್ಕಷನ್, ದೀಸ್ ಆರ್ ದಿ ಎನರ್ಜಿ in the form of waves and this is mass. Okay, next. What is the important thing in radiation? Okay, see, in radiation what happens? They travel in waves. And how do we come to know of radiation? How do we come to know of radiation? Radiation is anta heng gotagutte? Look here, light is a radiation. If you close your eyes, can you see light? No. Am I clear? If you close your eyes, you cannot see light. You cannot experience light. That means the light is experienced by our sight, sense. So sight, and it's one of a sense. ಸನ್ನಿಂದ ಹೀಟ್ ಬರ್ತಾ ಇದೆ, ಅದು ನಮ್ಗೆ ಏನು ಗೊತ್ತಾಗ್ತಾ ಇದೆ? ದಟ್ ಈಸ್ ಅ ಇನ್ಫ್ರಾರೆಡ್ ರೇಡಿಯೇಷನ್. ನಮ್ಮ ಕೈ ಮೇಲೆ ಬಿದ್ದಾಗ ಬಿಸಿ ಆಗ್ತಾ ಇದೆ. ಸೊ ವಿ ಕಮ್ ಟು ನೋ ದಟ್ ದೇರ್ ಇಸ್ ಸಮ್ ರೇಡಿಯೇಷನ್. ಸೊ ಇನ್ ದಿಸ್ ಕೈಂಡ್ ಬೇರೆ ಬೇರೆ ರೇಡಿಯೇಷನ್ಸ್ಗಳು, ಯು ವಿ ರೇಡಿಯೇಷನ್ಸ್ ಆಗಲಿ, ಎಕ್ಸ್ರೇಸ್ ಆಗಲಿ, ಬೇರೆ ಬೇರೆ ರೇಡಿಯೇಷನ್ಸ್ಗಳು ಮಕ್ಕಳ ನಾವು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿದ್ವಿ. ಸರ್, ಎಲ್ಲದನ್ನು ಯಾವ ಥರ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿದ್ವಿ? ದೇರ್ ಆರ್ ಮೆನಿ experimental setups, there are many scopes, okay, which can recognize these radiations. So these radiations are experienced. These radiations are experienced. Let me write here, experienced here. Okay, then see, here we have discussed the mode of propagation. Radiation travels as wave, but what happens in case of matter? Okay, see, whatever the matter, okay, If the matter is under the application of single force, if you apply a force onto the matter, it will try to move along straight line. If the only force applied, if we consider the only force applied, ಈಗ ಅಕಸ್ಮಾತ್ ನಾವು ಯಾವುದೋ ಆಬ್ಜೆಕ್ಟ್ ಎಸಿತೀವಿ, ಸರ್ ಅದು ಬೆಂಡಾಗಿ ನೆಲಕ್ಕೆ ಬೀಳ್ತಾ ಇದೆ, ಸ್ಟ್ರೈಟ್ ಲೈನಲ್ಲಿ ಹೋಗ್ತಾ ಇಲ್ವಲ್ಲ, ಯಾಕೆಂದರೆ ಅದರಲ್ಲಿ ಗ್ರಾವಿಟೇಷನ್ ಫೋರ್ಸ್ ಕೂಡ ಆ್ಯಕ್ಟ್ ಆಗ್ತಿದೆ. ಅಕಸ್ಮಾತ್ ಗ್ರಾವಿಟೇಷನ್ ಫೋರ್ಸ್ ಇಲ್ಲ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ, ನಾವು ಯಾವುದಾದ್ರೂ ಆಬ್ಜೆಕ್ಟನ್ನು ಥ್ರೋ ಮಾಡಿದ್ರೆ ಇಟ್ ಟ್ರೈಸ್ ಟು ಮೂವ್ ಇನ್ straight line. That you can take this for an example. If we shoot matter, it tries to travel in straight line. So matter travels in straight line, under the application of single force, under the application of single force okay. So you have got it. Okay, so now these are experienced. Okay, now do we experience mass? Mass is visible, mass is a definite volume. Okay, so when we come to matter, it has finite mass acquires volume. So these are the important things. Next, when you come to the radiation is continuous form of energy. The light is coming, it is continuously giving us energy. Sunlight is coming, heat waves from the sun is coming, and energy is continuously given. Now look here, let me assume these are the particles. If I throw this onto the ground, it will carry around 10 joules of energy to the ground. Okay, if I throw this, another 10 joules. If I throw this, another 10 joules. So here 10 joules, 10 joules, 10 joules. In between 10 joules, no, 11, 12, 13, 14 ಈ ಥರ ಇರಲ್ಲ. That means when we come to the matter, the energy carried by them is finite, discrete. They are not generally continuous. Whereas the waves, they are continuous form of energy. Okay, so now let me write that. They are continuous. And where these are not generally continuous. These are finite and discrete. Okay, next point. What are the examples? What are the examples for this? Light is also radiation, UV rays, X-rays, and other form. And how do these matter carry energy? Matter has got momentum. Energy will be in the form of kinetic energy or potential energy. Kinetic energy ಗೆ ಮಕ್ಕಳ ಶಾರ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ, ಸೊ ನೀವು ಅಪ್ಡೇಟ್ ಮಾಡ್ಕೊಡಿ. Look here, generally if you say that matter has got some energy, that means that this matter has got energy, potential energy, due to its position or change in configuration, or it has got some kinetic energy because of the motion associated with it, or it may have momentum. If we say mass, if it is under the motion, then we say it has got some momentum. What is momentum? Quantity of motion. ಯಾವುದೇ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಬೇಕಿದ್ರೆ ಅದರ ಹತ್ರ there is a quantity of motion, so it has got some quantity of motion, and that quantity of motion is what? Momentum. If you say something has got momentum, that means it is moving. There is some matter, it is moving. Am I clear with this? Now let us take a quick recap. Look here, radiation, they move in the form of waves. These, they move in straight line. Matter has got mass, and radiation, does it go to mass? As of now, no. Okay, then radiations are experienced, and mass, they are finite, they have got volume, they are stored in the many forms. Okay, And these radiations, they are continuous, where these are finite and discrete. ಅದಕ್ಕೆ ಇಷ್ಟಿರುತ್ತೆ ಅಂತ ಇರುತ್ತೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಅದಕ್ಕೊಂದು ಸೈಜ್ ಇದೆ, ಅದಕ್ಕೊಂದು ವಾಲ್ಯೂಮ್ ಇದೆ, ಅದಕ್ಕೊಂದು ಮಾಸ್. Okay, so and what are the examples? Light rays, X-rays and UV rays and many others. And what is the example for matter? You can set it proton, electron and etc. Neutron. If you say proton, electron, neutron, everything is included, because everything has got this only. Am I clear with this? So right now, look here. These are the characteristics of matter, and these are the characteristics of radiation. We thought these are the characteristics only possessed by matter, and these are the characters only possessed by radiation. But in last 2 centuries, there were many inventions which suggested and proved that matter also moves as wave. Matter is moving as also in the form of waves, and matter as also converts into radiation. Radiation converts into matter. So that is what our famous E is equal to mc square is. Energy matter agi matter energy agi convert agutte anta. So we knew with the advent of Albert Einstein. Look here. Does radiation has got mass? Initially we thought no, it has got no mass. But after the invention, that we came to understanding that with the proposal of quantum theory, we came to understanding that every radiation carries the small pockets of energy called photons. That's what we are going to study in this topic. So what is the basically dual nature of this matter and radiation? See, initially children, we thought these are the characteristics possessed by matter, and these are the characteristics possessed by radiation. But after many inventions, matter also possesses these characters, and radiation also has these characters. That means radiation has also got the radiation has got the characteristics of radiation and as well as matter, and same goes with the matter. So we are now going to study about this dual nature of radiation and matter. So that is, ರೇಡಿಯೇಷನ್ ಯಾವಾಗ ಮ್ಯಾಟರ್ ಥರ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ, ಮ್ಯಾಟರ್ ಯಾವಾಗ ರೇಡಿಯೇಷನ್ ಥರ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ, ಇದನ್ನೆಲ್ಲ ನಾವು ಈ ಟಾಪಿಕಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Am I clear with this? Thank you. Children, generally at room temperature, okay, at room temperature, what happens in a metal? In the metal there will be free electrons. If I take one atom, okay, this will be nucleus, and there will be orbits around the nucleus where we will get electrons, okay. Electrons in the outermost orbit, try to understand this. Electrons in the outermost orbit, this is the nucleus, and this is electron in the outermost orbit. Distance between them is large. Because of that, the force acting on the electron, the attractive force acting on the electron is less. That means this electron is freely bound to nucleus, and these electrons, okay, here I have magnified this for you. Here, look here, this is nucleus, and all these purple dots are free electrons. What happens inside the metal? These free electrons, they can freely move from one orbit to another orbit, okay. They are loosely bound. So what happens, due to change in force, they will jump to the next orbit. They may come here, they may come here, they may come here. Because of this pattern of motion, there will be collisions. This electron may come in collision with this, and this comes in collision with this. So they are freely actually moving like this. Because of this movement, they have got some kinetic energy, so they will come to the surface with the kinetic energy. So generally, if it has got kinetic energy and if it travels in this direction, this tries to jump out of the metal surface. So this tries to jump out of metal surface, but can it jump out of the metal surface? Have we seen any electron? Are we experienced any electrons getting out of the metal surface? Answer is no. So important conclusion we need to make is at room temperature in the metals there will be free electrons, and these free electrons will have some movements inside the metal. There will be collisions. Because of the collisions they have got kinetic energy. They will try to escape out of the metal surface. When they try to escape out of the metal surface, what will happen? Look here. Now this is the metal surface, and there is one electron which tries to move out of the surface. Let me take like this. Look here. Generally this metal is electrically neutral, that is, it is uncharged. That means the total positive energy and negative energy inside the metal is equal. When the electron jumps, electron is negatively charged, and when it jumps there is a deficiency of electron in the metal body. Am I clear with this? ನೋಡಿ ಮಕ್ಕಳ, ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಮೆಟಲ್ ಸರ್ಫೇಸಿಂದ ಆಚೆ ಜಂಪ್ ಮಾಡಲಿಕ್ಕೆ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? ಜಂಪ್ ಆಗುತ್ತೆ. ಸೊ there is an electron which moves out of the, which is trying to move out of the metal surface. When it moves out, what happens? There is a loss of negative charge. Whenever there is a loss of negative charge, what happens? This becomes positively charged. This surface becomes positively charged, and this positively charged surface pulls this electron back into the metal surface. Electron jump ಆಗಕ್ಕೆ ಹೋಯಿತು. ಜಂಪ್ ಆಗಕ್ಕೆ ಹೋದ ತಕ್ಷಣ, ಜಂಪ್ ಆದ ತಕ್ಷಣ ಏನಾಯಿತು? ಆ ಸರ್ಫೇಸ್ ಏನಾಯಿತು? ಪಾಸಿಟಿವ್ ಆಯಿತು. ಪಾಸಿಟಿವ್ ಆದ ತಕ್ಷಣ ಎಲೆಕ್ಟ್ರಾನ್ ಏನು ಮಾಡ್ತು? ಇಟ್ ಪುಲ್ಸ್ ಬ್ಯಾಕ್ the electron. Am I clear with this? So now we are going to write the statement of it. Children, we have written the statement that at the room temperature electrons in the outermost orbit of an atom are loosely bound, and they are called what? Free electrons. And can these free electrons jump out of the metal surface? No, they cannot do it on their own. ಓಕೆ, ಅಂದರೆ ಅದರ ಹತ್ರ ಇರೋ ಎನರ್ಜಿಲಿ ಜನರಲ್ ಆಗಿ ಅದು ಒಳಗಡೆ ಮೂಮೆಂಟಲ್ಲಿ ಇರೋವಂಥ ಎನರ್ಜಿ ಮತ್ತು ಅಲ್ಲಿಂದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಸಿಕ್ಕುವಂಥ ಎನರ್ಜಿಲಿ ಅದು ಆಚೆ ಹೋಗಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಓಕೆ, when the electron tries to escape, what happens? The moment electron jumps out of the surface, what happens? The surface becomes positively charged and it pulls back. Bye ಹೋಗ್ಬೇಡ ಅಂತ ಕರೀತೀವಿ. ಯಾಕೆ? ಎಲೆಕ್ಟ್ರಾನ್ ಆಚೆ ಹೋದ ತಕ್ಷಣ ಸರ್ಫೇಸ್ ಏನಾಯಿತು? ಪಾಸಿಟಿವ್, and it pulls back. Now we will study it in more details so that we can understand next concept. Okay, this is the metal surface. Am I clear with this? And there is an electron which tries to jump out of the surface, and this, let us assume this electron has come here. The moment electron jumps out of the surface, tumba dura hogiralla, just tries to jump, it jumps out of the surface. The moment this jumps out of the surface, this surface becomes positively charged, and this electron, this is negative. Okay, so here we have got negative charge, and here we have got positive charge, and distance between them is what? R. So now when the charge tries to move out of the surface, what happens? This has become positive. Now we have got two charge system. Because of that there will be potential energy, and potential energy is what? K into minus Q into plus Q, that is Q into Q divided by R. Okay, let me state that the charge of the electron which is escaping is Q1, and the charge on the surface is Q2. So that we get this. Now look here, there is a potential energy associated with this charges, and also there will be force between them. Okay, this surface is exerting force. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಏನಾಗ್ತಿದೆ? ಫೋರ್ಸ್ ಆಗ್ತಾ ಇದೆ, ಆಚೆ ಹೋಗ್ಬೇಡ ಮತ್ತೆ ಎಳಿತಾ ಇದೆ, and that force is proportional to 1 over r square. Look here, when the r is small, the force exerted on the electron is more. Am I clear? So distance ಕಮ್ಮಿ ಇದ್ದಾಗ ಫೋರ್ಸ್ ತುಂಬ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So sir, can we get this electron out of this surface? Definitely we can get the electron out of the surface. ಅದು ಆಚೆ ಹೋಗ್ಬೇಕು ಅಂತಿದೆ ಅಲ್ವಾ? ಆಚೆ ಕಳ್ಸೋಣ. ಹೇಗೆ ಕಳ್ಸೋದು? Look here, if we apply some potential energy to this, not potential energy, energy to this surface or this electron. Generally this electron, if we supply some extra energy to this electron will get out of this charge system. and this will overcome the distance. Once it has got sufficient energy to escape the surface, it can move out of the metal surface. For that we need to give extra energy. And before that, let me ask you this question. The electron is trying to escape from the metal surface. Now what happened? The moment electron jumps out of the surface, what happens? The entire surface becomes what? Positively charged. And this positively charged surface just pulls the electron back onto the surface. Now, if this electron wants to jump out of the surface, it has to get extra energy. Extra energy ಕೊಟ್ಟರೆ ಮಾತ್ರ ಇದು ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ ಈ ಎಲೆಕ್ಟ್ರಾನ್ನ ಹೋಗಕ್ಕೆ ಯಾರು ಬಿಡ್ತಾ ಇಲ್ಲ? Positively charged metal surface. Am I clear with this? Who is stopping this electron? The positively charged metal surface. And this pulling force, please do remember pulling force, ಎಳ್ಕೊಳ್ಳೋದು, okay? ಎಳೆಯೋದು. Pulling force exerted by positively charged metal surface on the electron is what? Surface barrier. Barrier ಅಂತ ಹೇಳಿದ್ರೆ ಮಕ್ಕಳ ಅಡ್ಡ ಅಂತ ಕರಿತೀವಲ್ವಾ? ಬ್ಯಾರಿಕೇಡ್ಸ್ ಕೇಳಿದಿರಲ್ವಾ? ಬೇರಿಯರ್ಸ್ ಅಂದರೆ ಜನರಲಿ ಅದನ್ನು ಹೋಗೋಕ್ಕೆ ಬಿಡ್ದಲೇ ಇರೋದು, ಅದನ್ನು ಸ್ಟಾಪ್ ಮಾಡುವಂಥದ್ದು ನಾವೇನಂತ ಕರಿತೀವಿ? ಬೇರಿಯರ್ಸ್. ಓಕೆ, ಸೊ whenever the electron tries to jump out of the metal surface becomes positively charged and pulls the electron back onto the surface. And this pulling force is called as what? Surface barrier. ಆ ಸರ್ಫೇಸ್ ಬೇರಿಯರ್ನ ನಾವು ಇನ್ನೊಂದು ಅರ್ಥದಲ್ಲೂ ಕರಿತೀವಿ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇರಿಯರ್. ಸರ್, ವೈ ಡು ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇರಿಯರ್? ಯಾಕಂದರೆ ಈ ಚಾರ್ಜ್ ಮೂವ್ ಆದ ತಕ್ಷಣ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಕ್ರಿಯೇಟ್ ಆಗಿರುತ್ತೆ. ನಾವು ಆ ಎನರ್ಜಿನ ಓವರ್ಕಮ್ ಮಾಡಿದರೆ ಮಾತ್ರ ಸರ್ಫೇಸಿಂದ ಚಾರ್ಜಿನ ಆಚೆ ತೆಗಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಸೊ ವಿ ವಿಲ್ ರೈಟ್ ದಿ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್. ಥ್ಯಾಂಕ್ ಯು. See, we have defined what is surface barrier. So we have written the statement. Pulling force exerted by positively charged surface on the electron when it tries to leave the metal surface, and it is called what? Surface barrier. Electron na ಹೋಗದಲೇ ಅದನ್ನು ಎಳ್ಕೊಳ್ಳುವಂಥ ಫೋರ್ಸ್ ನಾವೇನಂತ ಕರಿತೀವಿ? ಸರ್ಫೇಸ್ ಬೇರಿಯರ್. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇರಿಯರ್. ವೈ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇರಿಯರ್? ಸರ್, ಪ್ಲೇಟಿಂದ ಚಾರ್ಜ್ ಆಚೆ ಹೋದಾಗ ಅಲ್ಲಿ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಸಿಸ್ಟಮ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ನಾವು ಅದ್ರ ಮೇಲೆ ಅದನ್ನು ಚಾರ್ಜನ್ನು ತೆಗಿಬೇಕು ಅಂದರೆ ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿನ ಓವರ್ಕಮ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದಿ ಥಿಂಗ್. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್, can we eliminate free electrons? Definitely we can eliminate free electrons. So free electrons can be eliminated by metal surface by application of external force. Application of external force. ಅಂದರೆ ಮಕ್ಕಳ ನೋಡಿ, ಇಲ್ಲಿ ಇದೊಂದು ಸರ್ಫೇಸ್ ಅಂತ ತಗೋಣ. ಈ ಫೋರ್ಸ್ನೆಲ್ಲ ಅಳಿಸ್ತಾ ಇದ್ನ, ಇದನ್ನು ಆಲ್ರೆಡಿ ಬರ್ಕೊಂಡಿರ್ತೀರ ಜಸ್ಟ್ ನಿಮ್ಮ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ಗೆ. ಸೊ ಇದನ್ನು ನಾನು ಅಳಿಸ್ತಾ ಇದ್ವಿ. ಓಕೆ, ಸೊ ನಾವು this is the metal surface and these are the free electrons. So you can give external energy and these electrons will be eliminated. Electron can come out of the metal surface. And sir, what do we call this process of eliminating electrons by providing external energy? So this is called elimination of electrons. Elimination of electrons. Elimination of electrons by application of external force, I made a mistake. Elimination of electrons by application of external force. Is called electron emission. electron emission. So, sorry, electron emission. Okay. Students, now we are discussing work function of metal. Remember this word, work function, it associated with metals. Sir, what is this work function of metal? Look here. There is a metallic surface, okay? There is a metal surface and we have got free electrons here. And I am writing only free electrons, I am not writing any atomic nucleus here, just free electrons. See, we will apply some energy which is equal to some 12 joules. I will say 12 joules of energy. If we give 12 joules of energy, these are the free electrons. They are freely moving in the freely moving inside the volume of metal. When we give 12 joules of energy, no electron is ejected, and we will increase the energy by 12.5. Still, there is no emission. And I applied 12.7 joules of energy. Suddenly, there is an emission of electron. Emission of electron. Emission of electron. Emission of electron. Okay. I applied 12 joules, no emission. 12.1, no emission. 12.2, no emission. 12.5, no emission. 12.6, no emission. If I give 12.7 joules of energy, generally we don't calculate it we don't count it in joules, we calculate in electron volt. Still, we have not introduced that word, that's why I am using joules. Both are the unit of energy, we can take it. So when I applied 12.7 joules of energy, there is an electron emission. Sir, if we apply 12.8, is there an emission? Yes, of course there will be emission. 12.13, yes, you can have it. But if you apply any energy less than 12.7, there will be no emission. So that means this is the minimum energy. Minimum energy for emission of electron. And this minimum energy for an emission of electron from the metal surface is called work function of that particular metal. Sir, yake ತರ ಹೇಳ್ತಿದ್ದೀರಾ? Because different metals will lose electrons for different energies. Okay, so we will write the definition of work function of metal. So what is this minimum energy? Minimum energy required to eliminate or free, or we will write like this: minimum energy required by an electron, by an free electron to leave surface of the metal. Surface of the metal is called as what? Work function of metal. Surface of the metal, and it is denoted by W naught or phi naught. Okay, W naught or phi naught. And sir, in order to remove the electron from the copper, what might be the energy? We will assume X energy is needed. Okay, for removing electron from aluminum, is the same energy enough? No, that will vary. For different metal, energy required to remove the electron from their surface is different. So leave it. Okay, so we will write the next statement. Different work function is different for different metals. If we apply lesser energy than work function of metal, will there be electron emission? Definitely no emission. Sir, can we have emission for the value of energy which is more than the work function? Definitely you will. So work function is the minimum energy for an emission of electron. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಹಾಕಿದ್ರೆ emission ಆಗುತ್ತೆ, but ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಹಾಕಿದ್ರೆ no, it is not possible. See, that is about work function. Next we are going to study about types of electron emission.